everyone. First and foremost, thank you all for joining us for our final seminar of the year. It is our great honor to welcome Professor Rodolfo Nayga from Texas A&M University as today's esteemed speaker. He previously served as president of the Agricultural and Applied Economics Association and is currently the head of the Department of Agricultural Economics at Texas A&M University. Additionally, he is a fellow of the AAEA and serves as the managing editor of the American Journal of Agricultural Economics. Today, Professor Nayga will present on the topic Circular Bioeconomy, Research Opportunities for Agricultural and Applied Economists. Please give Professor Nayga a warm round of applause.
Thank you. Thank you, Daniel. Thank you, everyone, for being here. It's good to be back. It's good to see Professor Han as your president as well. So we've known each other for a long time, as many of you probably know. So yeah, I've been back at Texas A&M for 4 years. So I'm going to talk about circular bioeconomy. How many of you have heard about this term? Many of you probably, right? Yeah. So I think it's a hot topic in the United States, and I'm going to show you as well that it's a topic that I think the US needs to do more compared to Europe and some parts of Asia, okay? So let me just summarize the environmental impacts of food and agriculture, and I think this is well known to many of you. So in terms of greenhouse gas emissions, about one-fourth, right, of the greenhouse gas emissions come from food and agriculture. And in terms of land use, 50% of the world's habitable land is used in agriculture, right? So substantial percentage of the land used in agriculture. And then 70% of global freshwater withdrawals are used for agriculture. So water is very important, and being from Texas, this is really a big issue for us in Texas. So I visit normally research and extension centers around the state in Texas, and every time I visit them, 80% of the time we talk about water for good reasons, right? So water issues are really important. And then 78% of the global ocean and freshwater pollution, 78% pollution is coming from agriculture as well, right? So climate change, obviously, so agriculture is a contributor, right, to climate change, but it's also significantly affected by climate change, right? So let me talk about losses and waste in the global food system. Ag residues and other losses prior to harvest account for 80% of all losses, right? So pre-harvest. But post-harvest are also quite substantial, losses post-harvest. Less than a third, for example, of the biomass harvested from crops is finally consumed by humans, okay? So in a few minutes, I'll talk about food waste issue as well. Apparently, South Korea is the leader in reduction of food waste. Is that right? It's the leader in the world in terms of food waste reduction. So it's very impressive. Really? Yeah, that's good.
You can see in the we have the lunch time.
Yes.
We have the nice
separate bins.
Table.
Okay.
And, like we have the rainbow system.
Okay.
To kind of nudging to reduce the food waste. So
Nice.
you have to put a small amount of the rice to eat. So we show the line.
Interesting. Yeah.
So I'll show you.
Okay.
Campaign, zero food waste.
Zero food waste. Yeah.
Yeah. So
Yeah. I wish we have that in the U.S. You know.
definitely. So we are very successful.
Yeah.
To reduce the food waste recently, and
And that's countrywide, right?
yeah, recycling is very impressive.
Yeah.
Yeah. So
No, that's
Yeah,
great.
yeah,
Yeah.
yeah, yeah.
So you're way ahead of the U.S. I think.
yeah. So we are using the RFID system to reduce the food waste.
Wow, that is
So
impressive.
So each household checked how much spend the food waste, they automatically check the send the information to the household every month.
Oh, so it's measured, it's weighed.
RFID.
Oh, that's amazing. I hope they collect that data. There's that data somewhere. I'm sure some economists are analyzing those data now, right?
Pamela is specialized.
Okay. Yeah.
Pamela made a presentation in the USDA.
I will check that out. Yeah. So these are just biomass issue, right? South Asia is obviously a big contributor for biomass emissions, right, and so on. And so the hidden costs, right, of the agri-food system is very high, right? According to this estimate by FAO, it's in 10 trillion US dollars, okay? So significantly large. But these costs is not just from the production sector, right, of agriculture. It's really across the value chain, if you will, okay? So this just shows you basically that across the value chain or supply chain, there are costs involved manifested throughout the supply chain. So I guess when we talk about greenhouse gas emission reductions, we shouldn't really just look at the ag production side, right? We should also take a look at the other components of the value chain. You may have heard about the big problem with excess nitrogen use, right? Excess nitrogen use. On top of that, there's very, very low nitrogen use efficiency. And this is a major source of water quality degradation around the world, right? And so that's another issue that contributes to the problem, to the global problem. So what is the bioeconomy? I think many of you know what the bioeconomy is. What I want to emphasize is the bioeconomy is not just about, it does not include just agriculture. It also includes forestry, aquaculture sectors. So we're talking about food, feeds, bioenergy, and other bio-based products, right? So those whole thing is called the bioeconomy. And there are different categories of the bioeconomy. So color-coded, if you will, right? So for green will be biofuels, blue, marine and aquaculture. There's a lot of talk these days, for example, about sequestration of carbon by algae, right? Brown, the waste products that we just talked about. Microbial, taking advantage of microbiome, yeah. A lot of our scientists at Texas A&M focus on microbiome and gut research, right? White, biomanufacturing and bioengineering, right? Producing insulin, vaccines through mRNA, and so on. So it's a big sector, if you will, right? This whole bioeconomy. I want to mention the European Green Deal because it's really one of the things that the US is trying to emulate, right? But we're way behind the Europe in this regard. So this started obviously in 2020, right? And the objective is no net emissions of greenhouse gases by 2050, right? And I guess what I want to emphasize from this slide is that the bioeconomy will be a major enabler for several of these areas, right? On this particular graph. So EU wants to be a global leader in terms of basically reducing net emissions from food and agriculture. And consequently, they've had a lot of initiatives in the last few years, right? I want to highlight the top one is the initiative, for example, to really reduce microplastics. So microplastics is a big issue all over the world, right? Yeah. And there's quite a significant number of papers now indicating that the food that we eat really contain a lot of microplastics now, right? There's a lot of microplastics in ocean, for example, that the marine animals feed on and so on. And is that a big issue in Korea as well, microplastics? Yeah. it pains me that in Texas, we don't really, they don't think much about plastic waste, right? Not yet, anyway.
Texas is big.
Texas is big, and as you all know, it's a conservative state, right? But it just pains me that even at the university, at Texas A&M University, there are recycling bins, but very few, right? Here in Korea, they're all over the place, right? Recycling bins. So, and then the use of plastics is just not ingrained in the minds of people to really minimize the use of plastics. Okay. But as you all know, there's a lot of initiatives around the world on really reducing plastic waste. Okay. What are some of the initiatives in Korea that's being used to reduce plastic, usage of plastics?
So the recycling.
Recycling, obviously, yes.
You can see that we always separate the plastic and vinyl
Yeah.
and others, and we also separated plastic drinking.
The type of plastic?
Yeah, that type. But there is a lot of education. We educate the children,
Yeah.
so that you take out some label, plastic label, and we have the clean bottle, clean plastic bottle, and we use the recycling.
Oh, wow. Yeah.
And if we have the milk pack, so every housewife teach the children clean the milk bag and put the recycling pack. Something like that.
Yeah.
Because if not, so there is a bacteria, so it is very hard to recycle the milk pack.
Yeah. That's great, yeah. We could learn a lot from Korea then.
We are a small country. So
Apparently, I think there's quite a bit of emphasis now on the circular economy in Korea, right? So I just want to show that. So what's the difference between a linear versus a circular bioeconomy, right? And I think these figures here really depict it very accurately, right? So in a linear economy, if you will, so you create something, right? You make something, and then there's waste. But you don't really worry about the waste part, right? It's just waste. But in a circular economy, you make them, you use them, but there's really a lot of emphasis on recycling that waste, right? So that's the difference, in simple terms, the difference between a linear versus a circular economy. So a linear food and ag system would not adequately consider the value of natural resources and the environmental impacts. They tend to trap resources by disposing resources and impacting environment instead of reusing them. There's not much innovative solutions to overall challenges, right, in a linear system. On the other hand, in the circular system, you keep all the parts and materials inside the economy, right? Or try to at least do that. So unlike the linear economy, the circular economy, really the main goal here is to eliminate waste entirely throughout the whole system. Okay? And how do you do that? By designing products that are durable, reusable, repairable, refurbishable, using materials that can be recovered and recycled at the end of the life stage, right? So preservation of the natural resources, or reducing really the use of natural resources throughout, and reducing the need. It can reduce the need for landfills, consequently, if you do this. Right? So it's about closing the loop, if you think about it, right? So you reduce the waste, you recycle and reuse waste by increasing efficiency, and then you can also reduce environmental contamination by doing so. So the objective is to keep all the materials within the system and keep reusing them as long as possible. Okay. So outputs from one stage can be considered an input at another stage, right? Thereby increasing resource efficiency. And so if you do this, right, productive use of waste and organic residues can potentially displace fossil fuels as well. Right? So really, to be able to do this, you really have to take a systems approach or systems perspective to the problem, right? So not just one particular part of the system, you have to take a look at the whole system. Okay? And you have to recognize that low input use efficiency, right, implies waste and pollution. That's a big consideration or feature of a circular bioeconomy. So David Zilberman did some work on climate-smart circular bioeconomy, right? And this is what he said, is that there needs to be a multi-target strategy, really, to control climate change and the contribution of agriculture to climate change. And he mentioned these extra targets, if you will, should include sustainable resource use, pollution control, food security, biodiversity conservation, but he also included this issue of rural development. Okay. There was a study done by McKinsey in 2017, and it was a big study, and they concluded that circularizing the bioeconomy could boost Europe's resource productivity and really generate significant cost savings per year in terms of economic benefits. So there's an economic benefit as well of doing this, not just an environmental benefit, right, of circularizing the bioeconomy. But there's been limited work really on this area, especially in North America. So much of the published work, for example, on circular economy are in Europe, right, in some parts of Asia. In fact, only 71 published papers mention circular economy in economic journals, right, according to this annual review of resource economics paper in 2022. That said, I think there's an increasing number of economists now really getting interested in work related to circular bioeconomy. Okay. So some examples of subsystems that can help with circularizing the bioeconomy. Vertical farming, right? I don't know if Korea's got many of those, probably, right? Vertical farming, urban agriculture, right? Dairy production systems, right? Reusing nutrients and water. And then aquaponics, right? Basically cycling the resources between fish and crop production. Texas A&M has a big new initiative on controlled environment agriculture. And I'm part of one of the projects, research projects, really on this controlled environment agriculture. So, and the objective here is really to lead the industry and prepare students as well for the future of farming. Okay. So as Dr. Han mentioned, Texas is a big state, right? But 70% of its population is urban, right? And so urban agriculture, there's a lot more and more emphasis on urban agriculture. Hence vertical agriculture and controlled environment agriculture. There's also increasing work on enabling circularity in grain production systems. A lot of new technologies actually being tested to circularize the grain production systems, right? I mentioned about food waste reduction, right? It's a big emphasis, especially in Europe. So the EU member states basically has a commitment to reduce food waste by 10% and by 30% jointly at the retail and consumption levels. Okay. So some novel technologies, examples that can reduce food waste and help circularize the bioeconomy is this use of CRISPR technology, right, to reduce browning in bananas, for example. So bananas are one of the most demanded fruits, right, around the world. So if you can basically extend that shelf life using this non-browning technology, there'll be less waste at the retail level, right, and consequently improves and circularize the economy. There's also non-browning technology now in lettuce, right? Once again, these non-browning technologies can prolong shelf life, basically. That's the objective of it, right? So it can last longer. And then a lot of emphasis on not just carbon neutrality, but carbon negativity, right? So it's not just enough to be carbon neutral, it has to be carbon negativity, right? So what does that mean? It really is about emitting less than 0 greenhouse gas emissions. How is that possible? One pathway by offsetting more than one emits, basically, right? So offsetting more carbon through carbon capture, right? Sequestration, and so on. I just saw a news clip about a few weeks ago saying that carbon sequestration in the land is going to be an issue because there'll be a point when the soil cannot really sequester carbon. So if you think about it, take a look at a jar, right? A jar full of sand, for example. If you pour water on that jar with sand, it will absorb water at some point. But at some point, if you keep pouring the water, that water is going to overflow, right? And it's not going to be absorbed by the sand. So that's what's happening as well with soil, is we can't just rely on soil to absorb or capture carbon forever, right? There are points of time when they can't no longer capture or carbon. Okay? That said, there was a new technology developed at UC Berkeley. It was a compound that they've developed that can capture carbon through the air with this compound. I don't know if you've heard about this. This just came out 2-3 weeks ago. So it's a promising technology. I think the issue there is, I don't remember the name of the compound or the substance that can capture carbon from the air using this substance. But my issue there is the scalability, right? Whether that can be really scaled in a widely, if it can be scaled widely to really make a big difference. Okay. You've heard of microbiomes, right? Biochar, right? A lot of work in the US and around the world on these things. Robotics and analytics, right? For precision and regenerative agriculture. It seems like every semester in my university, there's a conference on precision and regenerative agriculture. Is that happening here too in Korea? There's a lot of emphasis on precision agriculture. And then negativity via biorefining, right, with anaerobic digestion, obviously fermentation, pyrolysis, and gasification. Okay. I'm sure many scientists in Korea are focusing on this one. Yeah. Oh, is that from me? Okay, I didn't know. The good news is there's quite a bit of corporate commitments now, right, to carbon sequestration and removal. Now, there's obviously the issue of greenwashing, right, by some of these companies. But I think more and more companies are really serious about this, right, because they can benefit as well from really committing to carbon reduction in greenhouse gas emissions. It's a good public relations as well for them, obviously. So there are a lot of benefits for circularizing the bioeconomy, but I think one limitation at the moment is that they view zero waste as an end goal rather than a means to an end, which is really to improve human well-being, right? And I'll talk more about this in a minute when we talked about, is that coming from me again? No. When we talk about One Health, okay? And so the circular bioeconomy concept at the moment still does not really provide a mechanism, right, to determine what is really the optimal level of circularity, right? So is there an optimal level of circularity for different sectors? Maybe there is, right? And I think that would be a job for us economists to figure out, right? And so if this is of interest to you, I think that area, that research area can be a good topic to pursue. So Madhukana, for example, mentioned that the circular bioeconomy does not consider trade-offs between higher levels of circularity, right? And social justice, right? So there's really no discussion yet about how circularizing the bioeconomy can affect social justice and equity issues, right? Like environmental justice. Right? And so there's also it does not also identify the optimal mix of pathways. Yes.
Oh, I'm sorry.
Yeah.
I'll just use some noises. Could you change the mic to this one?
Instead of this one? So it does not identify the optimal mix of pathways, right, to circularize the economy, as I've mentioned. And then there are trade-offs and synergies as well among the many technological pathways. And again, that's where economists can really help, right, is figuring out what these trade-offs are, and even unintended consequences, right, of policies that can improve the bioeconomy. So how can economics contribute? How can we contribute to this topic? I think one area of research is figuring out the behavioral barriers to technology adoption, to adoption of new technologies, right? And also ex-ante assessment of, the public's willingness to pay, really, in the adoption of these new technologies that can help circularize the bioeconomy. So I think technology adoption area is important, I think. Understanding why there's resistance to circularizing the bioeconomy is also an important area. For example, are there policy distortions out there that can be improved, right? Policies that can be improved. And how can we, for example, nudge the public to increase valuation and their willingness to pay, really, for some of these technologies that can circularize the bioeconomy and reduce waste. So I think as economists, that's another area that we can significantly contribute. And then obviously the welfare economic framework for optimally internalizing a lot of these externalities. And some of you are probably environmental economists here. Non-market valuation of the benefits of environmental protection would be an important area as well to contribute. Another one is the economics of alternative pathways, right, to circularizing the bioeconomy, because there will be trade-offs as well for these different pathways, right, and multiple environmental dimensions. So quantifying these trade-offs, right, for the different approaches to circularize the economy is really important. And then let's not forget, again, the whole system, right? Analyzing, basically considering the whole system or the whole supply chain and the interconnectedness of the activities across the supply chain or value chain. Because that's really the only way we can figure out what the spillover effects, right, from one sector of the supply chain to another. Also the unintended consequences and effects, and the partial and general equilibrium effects as well. So I think the use of this integrated economic ecological modeling would be important, I think, and it could be a contribution for economists. I saw this paper recently that was published in JEEM, Journal of Environmental Economics and Management. And the title really attracted me. It says, "On the Perils of Environmentally Friendly Alternatives." And what they did here was they figured out, they examined basically the use of plastic bags by the public versus biodegradable bags. And what they found is that by offering biodegradable bags for free, it really produced like a rebound effect and increased the use actually of more bags and more plastics. And so what they found is that it's not, when you introduce these new technologies, right, environmentally friendly technologies like biodegradable plastics or bags, don't just give it to the public for free. Put a little bit of price on it, right? Otherwise, there can be a rebound effect. So this is just an example of how we can contribute, really, right, in terms of producing the science behind this. So I mentioned earlier that one challenge, really, is determining what is the optimal level of circularity, right, in the bioeconomy. And that's very challenging, I think, to estimate and to analyze. And it can be domain-specific. It could be sector-specific, right? And we all know that, privately optimal level of circularity will be zero if the marginal cost is very high and the private benefits are very low, right? But as those things adjust, as marginal cost declines and the marginal benefit increases, then potentially we could figure out basically that optimal level, right, using marginal cost and marginal benefits. But the issue there is we need to be more creative in figuring out and getting the data, really, to be able to estimate that optimality. And as I mentioned, it can differ. It can be very domain-specific or sectoral-specific. I do believe that regulations, right, taxes, subsidies, can be helpful, right, in circularizing the economy. So policies, right regulations, optimal regulations and policies can help in terms of increasing the circularity of the bioeconomy. So let me mention this One Health, right? Have you heard about this concept, One Health? So it's a very interesting concept. And just to summarize, it's really about being able to not just think of animal health separately from human health, separately from environmental health. So the concept of One Health is the importance of really taking a look at holistically, right, between human health, animal health, and environmental health. And this concept, I think, became more salient and more important given the pandemic, right? So this became more salient as a really important topic because of the pandemic. So if you think about it, it makes sense, right, to really take a look at all these three components. And what I'm arguing is I think there's quite a bit of research needed, right, on the relationship and synergies between circular bioeconomy and the One Health concept. I do think that they can complement each other, right? But there's really not much work yet by economists on this topic about the synergies and relationships between circularizing the bioeconomy and the One Health concept. Okay? Other needs, I think there's need as well to educate the public, but to start educating our children when they're young, right? So make these concepts, for example, part of the curriculum of school children. There's also the challenge of influencing policymakers and policies. So science communication, right, is very important. Unfortunately, we're not well trained as economists, right, to really communicate our research. But I know that KREI, that's one of the strengths of KREI, right, is communicating basically science-based evidence to your policymakers, right? Because that's just like the economic evidence-based policy, exactly. And Economic Research Service in the US, that's one of their main focus as well. So let's not forget about the importance of the political economy, right? Because regulations and policies can really make a big difference, right? If they're the correct policies. But that said, we have to do more than just publishing, writing the reports, and so on. We have to be able to explain to policymakers the importance, right, of the evidence, the science-based evidence, as Dr. Han mentioned. So there's really a need for supportive policies, right? So research and development, R&D, are very important. Unfortunately, in the US, there's been a significant reduction of R&D in food and agriculture since 2012. So that's a major concern, is the reduction in investment in ag R&D in the last 10, 12 years. How is it here in South Korea in terms of your ag R&D? Has it been stable, increasing, or reducing as well? Okay, yeah. Has it been stable? Because it's been decreasing in the US, you know, in terms of for agriculture? Drastically. Okay. Yeah. So we talk. Yeah. Go ahead.
The economy is very uncertain next year, so that
I
we
see.
are concerned about the domestic economy demand reduction. So everybody is concerned reduce the consumption.
I see.
Personal consumption significantly. Because our political and economic situation is not good, and the US dollar is very strong. So
Yeah.
maybe we import about 80% food over the world, so that there's an imported food price is increased. It is affect the domestic general price level.
I see.
And now is people is complaining food price is too much increased, so that they realize that
Yeah. Yeah.
they kind of emotionally they think about 20% increased in the
In food prices.
Yeah,
I see.
yeah. But it's actually it increased about 5-6%.
Yeah.
But it's people realize
Yes.
because they go to the market is every day. So,
Yeah. Yeah. And you know, we all know about price asymmetry in terms of
yeah.
price increases and decreases, right? That's happened in the US too,
Yeah.
right? And that's probably one of the economic anxiety caused by the recent inflation,
Yeah.
I think was one of the determining factors in the election, to be honest with you. Right? In the US, in the US. Yeah.
Psychological
Yeah.
impact is very important.
And they see in the supermarkets that prices significantly increased during high inflation. Even though inflation in the US has significantly decreased, they're not seeing the reduction in prices in the retail stores, right? The price reduction rigidity is there, as we all know. So anyway, so science-based regulations, I think there's also need to incentivize farmers to adopt new technologies that can circularize the bioeconomy, and really support for carbon reducing initiatives, including sequestration, are also important. So need for interdisciplinary work. I know that KREI is also multidisciplinary in nature in terms of the social science, right? So what I'm arguing here is that no discipline alone can tackle the problem really of transitioning from linear to circular bioeconomy. We really need to work with our colleagues in other disciplines, right? And that's been an emphasis in in my university. So even in my department, I've really communicated to my faculty that it's important and it's highly valued for them to collaborate with other disciplines, right? So, and it's a no-brainer really in the US because a lot of the big grants that are available require multidisciplinary, transdisciplinary teams, right? So if you want to get the big grants, you don't really have a choice but to collaborate, right, with other folks in other departments and other disciplines. Okay, so it's important to, I think, as I've said, to work with other disciplines to be able to achieve this. So we need to learn what other disciplines know, right? We need to know what are the challenges as well, not just in our discipline, but in other disciplines. You know, plant science, animal science, biochemistry, biophysics, you name it, right? Data science. So what data do they have that could potentially be useful for us, right, as economists, and really figure out how we can collaborate with them in a more consistent manner. So figuring out mechanisms that will allow us to work with other disciplines really is very important. Okay. So that's all I have. Any questions? Yeah.
Last year I suggest circular economy as a research topic.
What is?
I suggested circular economics as a research topic of our institute.
Okay.
But when I think about the circular economy, the one question I have is that what is the optimal of circular
Yes.
economics?
Yeah.
So most of publication studied circular economics. They consider CO2 emission as one of the most important criteria to find the optimal level of circular economics. But in the South Korea, it is difficult to achieve reduce CO2 emission by using circular economics, I think. So we need another criteria to find optimal mix of bioeconomics. So
Yes.
if you have any idea about the critical factor of bioeconomic outcomes, then we can find it would be very helpful to find the optimal level or optimal mix of bioeconomy or circular economy policies design.
Yeah, I agree. And not just CO2, methane is also important, right? Especially in animal agriculture. So all these things, you know, greenhouse gas emissions are really important to reduce. The good news is I think there's really a lot of novel technologies out there that can make a difference, I think. You know, many scientists around the world are working on developing new technologies all the time now to that can have significant environmental benefits, right? But it's our job as economists to figure out really, you know, the unintended consequences, spillover effects, and optimal use of these novel technologies. And if these novel technologies are really that important, right, we also have to figure out how we can nudge the public and the consumers to value them, right? Because if the consumers won't value them, the farmers would likely not adopt them, right? And so it's not just technology adoption at the farm level by farmers, it's also important to take a look at consumers' willingness to pay for products produced by these novel technologies, by these new technologies. So we have to do both of those things.
I think it is very challenging to analyze the circular economy because the linear economic system, we apply the partial analysis.
Yes.
Yeah, do you understand?
Yeah.
So each stage, but it's circular economy itself, it represents the general economic analysis.
exactly, right.
It is very hard. Which one is endogenous variable, which one is exogenous
Yeah.
variable? Yeah.
No, that's what I'm saying. It's challenging. Yeah.
Everyone is
And you have to have the data too.
yeah, so
Yeah.
it is very, very complicated.
Yeah.
So therefore, is maybe all resources circle all the time. So it is a general dynamic. You have to solve the dynamic
Yeah.
general equilibrium model to get the optimal solution.
Right.
Yeah. So it's
Yeah.
challenging.
Yeah, that's a really good point. And that's why we've actually, in our graduate program, in our PhD program, we've reinvigorated our dynamic stochastic modeling classes. Many of our PhD students are really interested in environmental economics, obviously, environmental natural resource economics.
Yeah,
So many of them are very interested on topics like this, right?
Dynamics
But we have to have the tools. Yeah.
I think it is a dynamic
In gen-
stochastic problem is not challenging so much, but it's a dynamic stochastic
General equilibrium, yes, yeah,
very,
yeah,
very challenging.
right.
Yeah, so
Anyone here who got their PhD from Purdue? So what's the G? Okay. So the GTAP models and so on, right? In terms of trade, maybe that can be used as a model for other things. Yeah. But it is challenging. It is, but that doesn't mean we should not do it, right? Just because it's challenging.
and also it is not linear. It is non-linear. So
It is nonlinear,
yeah,
right?
so GTAP is a linear model.
Yeah,
so
that's true.
It's very simple
Yeah.
to solve.
Did you have a question or a comment? Yeah.
Thank you for the lecture, first of all. And in terms of circular economy, I used to think, especially for wasting, I wonder if, like, I know that consumers have incentive to reduce the waste because that saves cost. But for production part, do producers have incentive to reduce the waste? And I'm not sure about that. For farmers, they have incentive to reduce the fertilizer, pesticide, and so on, but not for reducing their production scale, right? So,
Like you mean waste? You mean losses?
I mean, yeah, because it's depending on in which stage they want to reduce the waste. But yeah, I think for producers, if they produce more, then that's the best.
Yeah.
But maybe for food processors and consumers, they want to decrease their waste. So, and me, I'm studying econ, and when I describe our economy, ag economy, the first term is that, oh, our GDP of agriculture is this much, right? And then that makes me wonder, do we have enough incentive to reduce the waste? I know that for producer, because I'm studying production part, maybe
Yes.
that's why I'm struggling to find incentive. But maybe for food sector, they have abundance of incentive.
Yeah.
So that's something that I feel, oh, that's ironic.
So farmers are obviously very interested in making money, right? They're doing it to make money. And so it's very important to really incentivize them to adopt new technologies that can reduce food losses and waste. And that's really part of the job of us economists. That's where we can contribute, I think, is to figure out what can incentivize, motivate them, right, to adopt new technologies that can improve the environment, that can have environmental benefits, right? Because if they don't see that they can make a profit, right, from adopting these new technologies, they're not going to adopt it, right? And that's where policy incentives can matter, right? Subsidies and so on, and taxes. But it's our job as economists to really analyze the impact of those. And what's the optimal regulation, right, to incentivize farmers' adoption of these new technologies. And on top of that, we have to also investigate if there are unintended consequences, right, in terms of the adoption of new technologies. So we have to have an open mind that not all new technologies can be very, very beneficial, right? Some of them may have unintended consequences in other sectors, for example. So it's a big job if you think about it, right, for us. But that makes us also a very, very valuable partner, right, in multidisciplinary teams. So many of my faculty have been quite successful in multidisciplinary grants. And it's not necessarily because my faculty approach the other people in other departments. It's the other folks in other departments that actually come to us as economists because they know that they really need the economics part, right, to be able to have a holistic project. And it really helps them as well sell their project, you know, to USDA or other funding agencies like the NSF. So, but it still helps that people know each other and people know each other's work. So part of my job as a department head is to really introduce them and develop mechanisms to get my faculty, the work of my faculty be known by other scientists within our university. Because it's important for people to know each other's work, right? But it's also, the personal touch is also important, right? It's also important to have good personal relationships with your collaborators. There's a human element to everything, right? Because they will only collaborate with each other if they feel comfortable working with each other, right? So it's good to develop mechanisms that will allow them to really get to know each other, right? But also get to know each other's work and develop those personal relationships. Don't you agree? Because we can't force people we can't just force people to build teams, right? I think those need to be organically grow, right? Because as I've said, personal relationships matter. And trust as well matter a lot. Because you don't want to work with people that you cannot trust, right?
In Korea, we have a lot of conflict between the Ministry of Agriculture and the Ministry of the Environment, like USDA and the EPA.
Yeah.
So the goal, policy goal, agriculture farm policy goal is to maximize ag production. They don't care about some loss and waste, but is loss and waste is the Ministry of the Environment is responsible for the taking care of the loss and waste and water pollution and land pollution, something like that. So for example, farmer used a lot of the fertilizer and
yes.
pesticides so much,
Yes.
and they throw some of the can of the pesticide outside. But it's the Minister of the Environment concerned about clean the rural area, those things. Therefore, we may merge, maybe Minister of Agriculture, USDA merge the EPA in the future for the circular economy.
Yeah, I don't think the USDA, I do think they talk to each other.
Yeah.
And to USDA's merit, they've really incorporated the environmental part. They've really emphasized the environmental part in many of their programs.
Yeah.
So I don't think, at least in the U.S., obviously there's still conflict between each ministry and or department, but I've seen a lot of emphasis on environmental issues with USDA. And in their strategic plan, they've really emphasized the environmental part because of climate change. You can't really deny climate change, right? And so in many of the requests for funding, RFPs, for grants, the environmental component is highlighted a lot in many of the grant programs of USDA.
We know the Donald Trump
Yeah.
does not concern about the climate change at all. So maybe is
I don't know. Yeah, it will be interesting to see. I think the worry right now is The worry right now is what are the significant changes that can affect USDA. ERS, for example, 95% of ERS employees work remotely. Economic Research Service, right? Which is part of USDA. And so there's talk that the Trump administration will require federal employees, like ERS employees, to work, to stop the remote work and go back to the offices. And I think if that happens, I would say more than 50% of current ERS employees will just quit and find another job. Because they're all over the country. A lot of the ERS employees, researchers, economists, are working remotely all over the US. They're not in Kansas City or Washington, D.C. They're all over the place.
So they will resign.
I think just because of a number of reasons, right? Family reasons, you know. So that is one worry. Another worry is, I'm just hoping that, you know, you must have heard that Trump wants to create this office of, what did he call it? Government efficiency, something like that, right? Basically to reduce waste in the government. Yeah, with Elon Musk and this other crazy guy. What's his name? Anyway, are you broadcasting this publicly? You're not, right? Anyway, so the hope is that it's good to eliminate waste, right? Government waste. But I'm hoping that they will not eliminate research expenditure, research budgets, right? Because if that happens, that can even exacerbate the problem. So NIFA, for example, what is NIFA? National Institute for Food and Agriculture. It's one of the main programs, right, for research programs in USDA. And they fund a lot of projects in agriculture in public universities. And if that's significantly reduced, I think a lot of us will suffer, right? Because that's a big source of our grant funding in the US. So there's that worry, but I hope they're sensible enough to not cut research. In fact, they need to increase research expenditures and budgets.
We need more collaboration with the European economists, so that
Yeah,
concern
yeah.
about the circular economy.
Yeah.
Because the US is big, so that you
Yes.
don't have any pressure on the pollution or in land and the water.
Yeah.
So Europe is a small country, it's a lot of the burden on the water and the land.
Yeah, I agree.
Like Korea.
Yeah. I think Korea is collaborating with the EU in the Horizon programs, right? Yeah. I think there are specific funds with the collaboration of South Korea and Europe and the EU to do joint research, from what I've heard.
Dr. Song will come to will go to the Texas next month.
Yeah,
So
that's
that
good.
you work together, most of you work together.
Yeah,
Circular
look forward to having you. Yes. Any other comments? No?
So thank you. We now invite you to join us at our Think Lounge for a gathering. Those who would like to continue the conversation with Professor Nayga are welcome to move there. Coffee and other refreshments have been prepared for your enjoyment. Thank you again for joining us today, and please give Professor Nayga another big round of applause.